Hello, this is Doris Ann Mertz. Welcome to part 5 of our ACT math series. We're going to cover a little bit more about functions today. We're going to talk about the inverse of functions. We're going to talk about composite functions and quadratic functions. So let's get started with part 5. All right, the inverse of a function, if you ever see an f with a -1 up in the exponent area, that's wanting you to find the inverse of a function. So it's actually a simple process. What you'd have to do is take that function, substitute a y where the f of x is, and then step 2 is you swap out your x and y's, and then step 3 is you solve for y to get y back over here on the left side again, and that is the inverse of the function. So let's look at one that's on the ACT and do it. So f of x equals the cubed root of x plus 2. Which of the following expressions is equal to the inverse of f of x for all real numbers x? So first of all, we're going to switch it, make it f of x, turn that to y. So y equals the cube root of x plus 2. Then we're going to swap out our x's and y's. So we turn this into x, we turn this into y, and then we solve for y. To solve for y, we got to get rid of this cube root. We're going to cube both sides. So we're going to get x cubed equals y plus 2. And then to get y by itself, we got to subtract 2 from both sides. So we're going to get y equals x cubed minus 2. And we see that right there on F. The composite of functions is created when one function is substituted into another function. And you just got to remember, you got to always start with what's on the inside of the parentheses. It can be written like this, f of g of x. That's the most common way it's written. But the first time I saw it written like this, it really threw me. I didn't know what I was supposed to do. But that's just another way to write the composite function. It can be written f of g of x like this, or it can be written like this, or it can be written like this. I don't know what to call that little, little symbol, but it just means composite function. So given that f of x equals 3x plus 2 and g of x equals f of x plus 5, let's find f of g of x. So to find f of g of x, we start with the inside. So we start with g of x, and we put g of x, which is x plus 5, into the f function. So we put the x plus 5 in where the x is here. So we get 3 times x plus 5 plus 2, and then we just work it and solve that out. Similarly, when we're told to do g of f of x, we start with the f of x, which is on the inside, and that's 3x plus 2, and we're going to put that where the x is in the g of x function. So we're going to put 3x plus 2 plus 5 and solve that and get 3x plus 7. So these are the inverse functions, the composite functions of f of g of x and g of f of x. All right, here's an example. If h of x equals x cubed plus x and g of x equals 2x plus 3, then g of h of 2 equals what? So actually they're wanting us to put a 2 where x is to start with in the h of x function, and then we're going to put that answer into the g of x function. So let's just do that. So we're going to say h of x, so h of x is equal to the x cubed plus x, so we're going to put a 2 in there. So h of 2 equals 2 cubed plus 2, so it's 8 plus 2, so it's 10. Then we take that 10 that we got from h of 2 and we put that into the g function. So here's the g function, g of x equals 2x plus 3. We're going to put the 10 in there. It's going to be g of 10 equals 2 times 10 plus 3 equals 20 plus 3 equals 23. So the answer is J. Now we're going to talk about quadratic functions. Quadratic functions, when you graph them out, they make parabolas. So here's what y equals x squared. That's a parabola. It's just that has a vertex of 0. The standard form of a quadratic function is y equals ax squared plus bx plus c. And c is your y-intercept in that form. The factored form, a lot of times you have to factor it out to find the roots, and the factored form is y equals a times x minus r1 and x minus r2. And r1 and r2 are the roots or x-intercepts. The vertex form is less commonly found on the ACT, but the vertex form is y equals a times the square of x minus h plus k. And when it's written in this form, it's simple to look at and find your vertex, and that's hk. Your vertex is simply, if it's a positive parabola, it's a positive function where it makes a U, where it opens up, then that's going to be your lowest point, and your vertex is your highest point on a negative function, a negative parabola. Okay, let's look at what happens when you change that a. This black line is y equals x squared. This blue line is y equals 2x squared. So we see that as the a increases, the parabola gets more narrow because it increases more quickly. Now, if a ends up being less than 1, then it's going to make a more shallow parabola because it's going to increase more slowly. So this is just the standard y equals x squared. This is y equals 2x squared, and this one is y equals half x squared. Now, sometimes you can factor out a quadratic equation using the reverse FOIL, and sometimes you can't. Sometimes you have to use the quadratic formula, and the quadratic formula can be found right here. I don't know, you guys. At Custer High School, they teach them how to memorize the quadratic formula by singing it to Pop Goes the Weasel. So that's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's how they memorize that. You might occasionally have to memorize that. More often, you may just have to memorize this part, the b squared minus 4ac, that falls under the square root sign, and that is your discriminant. Sometimes you need to know the discriminant. It's the b squared minus 4ac. And what you really need to know about the discriminant is if it's positive, there's 2 real solutions. If it's negative, there's no real solutions. They're only imaginary solutions. And if it's 0, there's 1 real solution. That's where it hits at 0. So let's look here and just go over that again. So let's see it in action. This is when your discriminant is positive. When it's greater than 0, you have 2 real solutions. You have 2 places, 2 roots, 2 real solutions. You have 1 real root when the discriminant is equal to 0, and that is at 0, at y equals 0. And if the discriminant is negative, there are no real roots. That means it doesn't cross the x-axis at any point when the discriminant is negative. So there's only imaginary roots. So let's look at a few questions that involve functions. So which of the following is the graph in the standard coordinate plane of y equals 2x squared plus x over x? Now, I just threw this up there because it's actually a simple question, but a lot of people see this 2x squared and they think, oh, I'm looking for a parabola, and they cancel out all the straight lines and narrow it down to these 2 and choose from these. But this is not actually written in its simplest form. You have x's in all, so you need to cancel that out and reduce it down to its simplest form, which is y equals 2x plus 1. Now that we know it's y equals 2x plus 1, we know that we're dealing with one of the straight lines. That's the function of a line. And we know it's the one that crosses at the y-intercept and has a slope of 2. So that would be A. All right, you're giving the following system of equations: y equals x squared and rx plus sy equals t, where r, s, and t are integers. For which of the following will there be more than one solution with real number coordinates for the system? So we're looking at when there will be more than one solution. And what we're doing, we're looking for the discriminant in this problem. And when it's more than one solution, it has to be positive. With the b squared minus 4ac has to be positive. It has to be greater than 0. So knowing that we're looking, in order for there to be more than one solution, if it asked for one solution, we'd know the discriminant had to be equal to 0. But they say more than one solution, so we know it has to be positive, we know it has to be greater than 0, and that eliminates h, j, and k right off the bat. But then let's work it out. So first we got to put the y equals x squared, we got to substitute that x squared in for this y in this second system. So We put the rx plus sx squared equals t. We go ahead and minus t from both sides to set it equal to 0. And now we have quadratic function equal to 0. We have sx squared plus rx minus t equals 0. Now, remember, we're wanting to know, we got to find when the discriminant is positive. So the discriminant is b squared minus 4ac. So we're going to take the r and put it where b is. So it's going to be r squared minus 4a. That's the s. And then t is a negative t. So it's going to be minus 4s negative t. Those negatives cancel each other out. So it's going to be r squared plus 4st. So it's going to be f. All right, the three parabolas graphed in the standard coordinate plane below are from a family of parabolas. A general equation that defines this family of parabolas contains the variable n in addition to x and y. For one of the parabolas shown, n is equal to 1, for another, n is equal to 2, and for the third, n equals 3. Which of the following could be a general equation that defines this family of parabolas for all n greater than or equal to 1? And it shows us right here that this is n equals 1. The second one that gets more narrow is n equals 2. And the third one is n equals 3. So it's working just like we saw earlier. So we know, if we look at our answer choices, we know that it's going to have a y-intercept of 1. So we can eliminate choice C. We know that it opens upward. So we know that we can eliminate choices D and E. So we're only really looking at choices A and B. And since it follows the standard form and it's getting smaller as n gets greater, we know that this is the right formula, y equals nx squared plus 1. Excuse me. So the parabola gets narrower as n increases, so the y-intercept is 1, so the answer is A. All right, that's all I've got right now for quadratic equations. We're going to get into a little bit more complex math in part 6, and I look forward to seeing you then. Thank you for joining me.